So in this activity, you're being asked to come up with the equation for the inverse of the blue graph. If you would please plot the points that would represent the inverse points based on the given points, and then come up with the equation. If your equation is correct, your inverse and the blue graph should intersect at 1818. If you're unable to see all 3 points, left click on the graph, slide the graph until you're able to see the 3 points. When you're finished, turn the video back on. So 0, 6, its inverse would be 6, 0. For -2, -6, 2, its inverse is 2, -6. For -9, 0, its inverse is 0, -9. So notice that the points are all forming another linear function. So if you determine the slope and the b value, or the y-intercept, correctly, again, those 2 graphs should intersect at 1818. In the second problem, you're being asked to come up with the coordinates, the inverse coordinates for the parabola. Keep in mind, when we talked about the squaring function of the parabola in the last lesson, it is not a function. There are x values that have more than one answer. So to be able to graph the equation that would go through all those points, you actually have to write the equation using 2 equations. So you're going to have the top half of the graph is going to be a square root equation, and the bottom half of those points will fall on the second square root equation. So go ahead and plot the points, and then see if you can come up with both of the equations so that you can graph the entire, basically as a sideways parabola. When you're finished, turn the video back on. So 0, 7 would become 7, 0, 1, 4 is 4, 1, 2, 3 is 3, 2, 3, 4 is 4, 3, and 4, 7 is 7, 4. So this is kind of that sideways parabola, but again, at 4 there's 2 different answers, and at 7 there's also 2 different answers. So we cannot graph or write a simple equation for this graph. It's actually made up of 2 square root equations. So the vertex is at 3, 2. So we're going to use that vertex, so I'll go through the first one. So vertex is 3, 2, so that means that we're doing a shift of 3 to the right, so it's x minus 3. And then we're doing a shift up of 2, so that means the k value is a 2. And that would be the top half of this, this total graph. And so if you write the equation for the bottom half to complete the entire graph. Keep in mind that it's not a function because the x for these 2 x values, we have 2 different answers. When you're finished with the equation, move on to the next screen. So in this lesson, we're going to be looking at how do I find the value of an exponent when it's not a whole number or it's not an integer value. So one way of doing that is just simply guess and test. So for example, 2 to the x equals 46. There's not an actual x whole number value that will work. So what we do is we kind of guess and test until we find out between what 2 whole numbers gets me really close to 46. So 2 to the 5th is 32, and 2 to the 6th is 64. So the answer is somewhere between 5 and 6. So the next column are those values, decimal values between 5 and 6. So what I'm asking you to do is, using the calculator, can you determine what 2 consecutive decimal numbers will give me an answer that's really close to 46. And then the second problem, 4 to the x equals 231. Between what 2 decimal numbers will give me an answer real close? It's between 4 cubed and 4 to the 4th. But can you identify what a pair of decimal numbers will get me real close to 231? So without having any kind of rules, this is the way we would go through trying to solve these exponent problems. So when you're finished, advance to the next screen. So what we're going to look at today is developing some rules that will allow us to come up with these answers without having to go through a test and guess and test process. So the first thing I'd like you to do is graph the inverse of the function y is equal to 2 to the x. And when you finish the graph, turn the video back on. So if your graph is correct, it should look like this. So the points 3, 8 should be 8, 3, 2, 4 should now be 4, 2, 1, 2 should be 2, 1, and so on. So if you notice that for every value of x, there is only one answer, so the inverse actually is also a function. So what we're going to look at today is how do I find that exponent. And so we're going to introduce you to an idea called logarithms. And so when you have an exponential equation, we can actually rewrite exponentials as logarithms. So the general form is 100 equals 10 squared. That would be the exponential. And its log would be log of 10, which is the base, of 100, that's the answer, is equal to 2. And so logarithms, when set up correctly, the answer to a logarithm is actually the exponent. So we're going to use logs as our inverse to get to the actual exponent answer. So on the next screen here, you're being asked to take the exponential equations and rewrite them as logs, and take the log equations and turn them back into exponentials. When you're finished, there's a hyperlink. Just click here and you can access the answer key and see if you have the problems correct. If you need to revisit the form, go back to the previous screen. When you're finished, go ahead and advance to the next screen. So one of the things we've tried to emphasize throughout the Algebra 2, and probably your teachers in previous classes have as well, is that quite often there are numbers that are missing when we write symbols. So for example, the square root of 25, well, the number to the left of the radical sign, there's no number written there, even though the number actually is 2. It's the only radical that we write in which we don't indicate the number. So if it's a cubic root of 3, we put a little 3 to the left of that radical symbol. Well, on your calculator, you will probably find a log key, but you will not see a base. And so most of the time, your calculator, the base is missing. Now there are some calculators out there today that the base can be actually inputted, but in general, when there's a log button being used, the base itself will not show up. And so the question is, what is that base? Is it a single number, or is it more than one possibility? So log of 100 equals 2 is log base of what number of 100 equals 2. So can you find that number? And so you may find that problem to be easier if you solve it as an exponential, because this number here, the base number, and this number here, the base of the exponential equation, are the same number. So if you go ahead and solve all 4 problems and then answer the question, what base or bases did you find worked? When you're finished, move on to the next screen. So hopefully you found that the number 10 was being used every time. So the log base 10 of 100 equals 2 because 10 squared is 100. A log base 10 of 1,000 equals 3 because 10 cubed is 1,000, and so on. So if there is no base given here, it is always 10. No, there's no exception. When the base is missing, it's always 10. So you're going to be looking at 2 investigations, and what you're trying to do is decide, based on the problem, what kind of rules are we using to be able to hopefully simplify some of these problems. So for example, we spent some time looking at a power rule for exponents. We did a quotient rule for exponents. We did a product rule for exponents. So now we're going to come back and start developing some rules that involve logarithms. And again, keep in mind that logarithms are being used as a way of trying to figure out an exponent when we have an exponential equation and the exponent's unknown to us. So using your calculator, I'd like you to determine for the first 4, A through D, which of those 4 equations is correct. So put in log of 20, and then put in log of 2 minus log of 10, and see that both sides are equal to each other. Only one of those equations is correct. And then the bottom set, which is a different set of problems, I'd like you to go through the same exercise and decide which of those 4 equations based on your calculator is providing the right answer. And then please choose the correct answers in the checklist to the right. When you're finished, turn the video back on. So hopefully you determined in the first one that letter D actually worked. That log of 20 is equal to log of 2 plus log of 10. And on the bottom set, hopefully you also determined that the bottom one also worked. Log of 45 is equal to log of 9 plus the log of 5. So before moving on to the next screen, look at the problems that worked, and what kind of problems were they, what kind of numbers are being used, how are those numbers being determined, is there any kind of patterns that allow us to make some decisions about what's happening here. When you think you have some ideas, move on to the next page. So you have two more problems to do here, and again, same ideas. Which of the four equations seem to be working? Based on the previous screen, kind of predict, maybe put a star out here to the left of the problem you think is going to be the right one. Same thing here. Go through with your calculator, check the answers, see which answer on the top works, which one on the bottom works. Is your pattern working, or do you need to change your idea to maybe a different rule? When you're finished, turn the video back on. So hopefully you determined that the bottom one, D, and the bottom one here, H, actually both of those worked. So again, what's happening here for this particular log? So keep in mind there are different log rules, just like there are different exponent rules. And so this is just one rule, and we'll give it a name, but right now I'm going to call it law 1 for logarithms. What appears to be happening here that allows me to rewrite a logarithm problem? When you're think you have some ideas, we're going to go on the next screen. So go ahead and complete this set of problems. The next screen is going to ask you to determine which of the rules here is the one that you're using for the first law. When you advance to the second next screen, screen 14, you're going to be introduced to the second law and being asked to go through a series of problems and then answer some questions as you're working through. The last screen is asking you to complete the logarithm problems using the first law and complete the logarithm problems using the second law. So when you're finished with the activity, you should hopefully have an idea of two different laws for logarithms and how to rewrite one from a single log of a single number into one of those two laws. If you have any questions, let your teacher know.